So here's an example of doing an identity. So let's try to prove this identity. It's not going to be easy. There's a lot to it. The first thing we have to remember is that we make our right side left side, and it's not like solving an equation. So we can't move things over the left side, right side. Other thing we should remember is all the identities that we have at our disposal. So all these things look like they're compound angles, compound with a D. And I should remember that for pi by 12 minus x, I could use x minus y. And for sine pi by 12 minus x, I could use sine x minus y. Alright, so we take the time to write all that out. Right, and this is just pulling from my identities. And I make sure that my brackets are where they're supposed to be. So this part right here is cos pi by 12 minus x, and this part right here is sine pi by 12 minus x. Now I go to simplify. Well, I know that secant pi by 12 is 1 over cos pi by 12, and I know that cosecant is 1 over sine. So now I can start expanding into that bracket. So I get cos pi by 12 cos x over cos pi by 12 plus sine pi by 12 sine x over cos pi by 12. Then expanding the second bracket, I get sine pi by 12 cos x over sine pi by 12 minus and so on. Then I can see that the cos pi by 12 cancel out, and also the sine pi by 12s there cancel out. And I also see that there I have tan pi by 12, because sine over cos is tan, and here I see that I have cotan pi by 12. So, when I rewrite everything a little bit simpler, this is what I end up with. Right? Okay. So now, cos x minus cos x goes away, and I just have tan pi by 12 sine x plus cot pi by 12 sine x. And I can factor out a sine x, which is kind of exciting, because if I'm trying to prove this identity up here, I have my sine x. So really, I'm just hoping that all of that other stuff ends up being 4. And for all that other stuff, I can see that I'm going to need some compound angles, and I'm going to see what I can get. Okay, so let's continue on. So, this is what we have so far. I just want to remind you. And because I have cotan and tan, I want to change that into sine and cos, because those are easier for me to work with. If you don't want to, if you just want to go with compound identities for tan, that's fine. That'll work too. This is just what I like. And now whenever I have different fractions, I like to get a common denominator, because that usually cleans things up a bit. So I know sine pi by 12 cos pi by 12 is going to be my denominator. So cos squared and sine squared is my numerator. Now, I should know, it doesn't matter what the angle is, sine squared plus cos squared is 1. And that makes me happy, because I'll be able to simplify. On the bottom there, I have sine x cos x. Well, I know that that's part of the sine 2x identity. So sine 2x says that it's equal to 2 sine x cos x. Well, here, I don't quite have a 2, so that means that I need to get rid of that 2. Well, I just divide both sides by 2. So I have sine 2 pi by 12 over 2. And now, my numerator is simplified to 1, and my denominator has simplified to a half sine pi by 6, because it's a half sine 2 times pi by 12. And I know pi by 6, it's a half, and so I have sine x times 1 over a quarter, and I know that 1 over a quarter is 4. So there's my 4 sine x, and that equals to the right side, and that makes me really happy. So, moral of the story, take it a step at a time. It's not going to solve itself right away, but this is how we use all of our identities.